Project Management, Chapter 8. In Chapter 8, we talk about scheduling resources. So we've already looked at the project networks and creating project network times. However, now we need to schedule our resources. And we need to look at what resources are available and if their availability matches when we need them in order for the project to work. We look at our project network plan and our resources, and now we start making a plan about if we need to shift times or resources. So we're in our project planning process. We've done our scope and our WBS. We have our network. We've looked at risk. Now we're looking at resource and cost scheduling. All of those things go into our master project plan. We can look at resource smoothing or leveling, which involves to even out varying demands on resources by using those slack periods that we have available to us. Resource constrained scheduling is the fact that we might go over our time because resources are not available, especially if we have several projects running at the same time and those projects need the same resource and we have a limited number available. So we have several different kinds of project constraints. We have the technical or logic constraints. So this is related to our network sequence in which project activities must occur. A has to be finished before we can start B, or C, D, and E have to be done before we can move to F. Physical constraints are that some of our activities cannot happen at the same time for various reasons. So even if they are parallel on our network plan, our different resources, contractual agreements, environmental conditions might make us not able to do them at the same time. So then our resource constraints. Our resources are people, materials, and equipment. When we're looking at resource constraints, we have some examples here. So our technical constraints are that we need to, this is a house example, we need to pour concrete before we could put up the frame. The frame needs to exist before we can have the roof. In a software design, we need to design, then code, and then test the code. Then that's a technical constraint, that something has to happen before the next thing can happen. In a resource constraint, things can happen dependent on how many resources we have. So in example B, if we have 3 different people assigned to these things, so if we have one person purchasing refreshments, one person decorating the hall, and one person carrying the fan, then those things can happen simultaneously. However, if we only have one person carrying out all activities, they can't do them all at the same time, and things then go back to happening linearly. When we're looking at scheduling, we have either a time-constrained project or a resource-constrained project. So in a time-constrained project, we have a project that must be completed by a specific date. The time is fixed, but our resources are flexible. Additional resources might be required to ensure that the project meets the schedule, but we're able to pull in those additional resources. If we have a resource-constrained project, that means at some point the resources available to us to complete that project cannot be exceeded. Our resources are fixed. We have inadequate resources that can cause a delay in the project, but time is flexible. We can use our Slack. So when we're looking at our resource allocation methods, once an activity is started, it is carried to completion. So these are the assumptions that we have in our scheduling. Splitting activities is not allowed, and the level of resources used for an activity cannot be changed. So the risk with that is that activities with the most slack pose the least risk because they're the most flexibility. Reduction of flexibility does not increase risk, and the nature of an activity, whether it is easy or complex, doesn't increase risk. So we have these assumptions when we go into our resource allocation method. If it is a time-constrained project, it must be completed by a specific date. This requires that we use leveling techniques or those smoothing techniques that focus on balancing our resource demands. We want to use our slack available to us to manage resource utilization over the duration of the project. So our peak resource demands are reduced, the resources over the life of the project are reduced, and fluctuation in research demand is minimized. We'll look at an example here with a botanical garden. We can see that we need a backhoe. The BH stands for backhoe, and we're looking at the different project network things. So first we have our project network, and we can see that at our highest usage, we need 4 backhoes. And that is from weeks 4 through week 10. However, if we use the available slack and smooth out that project, you can see in the bottom grid that we've managed to smooth out those activities using our slack to reduce our resources needed from 4 backhoes at one time to 3 backhoes maximum at any given time. We still complete the project in 24 weeks. We've just shifted part of the week 4 through 10 activities to their late times during the 12 to 18 weeks. It doesn't do any detriment to our project, and it helps reduce the number of resources that we need. When we have resource demand leveling techniques for time-constrained projects, where we took the level of 4 backhoes needed for our botanical garden to 3 backhoes, then we can help to decrease our resource demands at peak times. The resources total needed over the life of the project are reduced, and any fluctuation in resource demand is minimized. So if we only had 4 backhoes available as a company in whole, we would help with that total resource demand. However, because we're taking advantage of the slack and that scheduling, we lose some of the flexibility in our schedule. This makes more of our activities critical activities. Now we're going to look at resource constrained projects. So resources are limited, either people or equipment. Then we use activity scheduling using the rule of thumb or heuristics. First, we go to minimum slack. We look at activities that have the minimum slack and adjust accordingly. Then we go to the smallest or shortest duration of an activity. And if both of those still have constrained resources, then we go to the activity identification number or letter and pick the lowest one first. So we look at the process starting at the first time period of the project and schedule period by period the start of any activities using these 3 priority rules. So first we would schedule the first activity and then move to the second activity and move any of that used our resources. So we're going to look at an example here. We have a network for a resource constrained schedule. So we have this software plan. For this project, we only have 3 programmers available. So you can see how, like in step A, we start with, but B, C, and D, we could be doing simultaneously. However, if we do B, C, and D all at the same time, we need 5 programmers and we only have 3 available. So we need to shift those using the slack available to a time that we don't have 5 programmers under demand. So we can see here we have our activity IDs, the number of programmers we need, and how they are stacked up. Our total resource load shows that weeks 2 through 8, we need more programmers than we have available. So we want to look at shifting those activities. We're going to start with the first activity that causes a resource overload. So we're through periods 2 through 3, we have a resource constrained schedule. So first we need to reduce one of the programmers available. We're going to look at first the slack available. And if we don't have slack available, then we go to the smallest duration. Is 2 or 3 of a smaller duration. Even though they can happen at the same time, what is the shortest duration? So then once we've rescheduled those, using our early start, late finish, and available slack, we're changing our resource load to having 3 available instead of the 5 that were original. So we're pushing piece 2 off by using the slack available for it. So now we've pushed 2 off to its late start date. So instead of starting it at week 2 and running it concurrently with 2, 3, and 4, we're waiting until 3 is finished so that we can start working on 2 because of our constrained resource. We're also going to end up adding 2 more weeks to this project because of those resource constraints, which gives us a new resource scheduled network.